Okay. Now, if the reactant or the product is a gas, we can measure its number of moles using the ideal gas law, assuming that we have the volume of it, the temperature of it, and the pressure, rather than, of course, the mass. And so if we were to convert a gas in a reaction, a reactant A gas to a reactant B, a product B gas, reactant A gas to product B gas, then what we would have to do is to use PVT information to convert volume of A, or whatever we have of A here, to moles of A. And then in the balanced chemical equation, we then do a mole-to-mole conversion, and the mole-to-mole conversion gives us moles of gas B, and then we use the ideal gas law again to give PVT results for gas B. All right? So the skill that we need to talk about now is to use stoichiometry and the gas laws to calculate the amounts of reactants and products. In other words, we're going to focus on this step and this step. Let's suppose the question is, what volume of hydrogen gas at 765 torr and 225 degrees Celsius will form 35.5 grams of copper from copper 2 oxide, given this balanced chemical equation here? Copper 2 oxide plus hydrogen gas goes to solid copper plus water vapor. Okay? Now, the question asks for volume. And it gives us conditions, and it gives us a mass of copper. So we might start with the mass of copper and convert that to moles of copper, and convert that to moles of hydrogen, and then use the PVT information to get the volume of hydrogen. Okay, that will be our plan, and of course we're going to have to use the ideal gas law in this last step. So let's start and do our mass to mole conversion, because we've seen a lot of those. Those are sort of ho-hum right now. The details look like this. 35.5 grams of copper times 1 mole of copper over the periodic table value, 63.55 grams, times 1 mole of hydrogen here to 1 mole of copper over here, and that gives us 0.559 moles of hydrogen. So mass of copper to mole of copper to mole of hydrogen. Now the last step, we need to summarize the gas variables because it's a gas law problem, right? The pressure in the atmosphere, in atmospheres, is 765 torr times 1 atmosphere over 760 torr, and this is of hydrogen. This gives us 1.01 atmospheres of hydrogen. Temperature 225 degrees Celsius corresponds to 498 Kelvin. So that looks pretty good. And to solve, all we have to do is use the ideal gas equation, solve for V. We put in 59.559 moles of hydrogen here. We put in R, 0.0821 liter atmospheres per mole Kelvin, times 498 Kelvin, divided by the pressure in atmospheres. And once all the arithmetic smoke clears, what we find is that moles cancel, atmospheres cancel, kelvins cancel, and the answer is in liters.